Hello. Yeah, I'm Satish Kumar. So I'm just going to explain you on the CAN protocol, how it has been used in the LabVIEW using XNET. So that's a different tool which has been developed by the National Instruments, and they have introduced this for the XNET, CLIN, and FlexRay use for using that in the LabVIEW. So we have to install XNET package from the NI package manager. So now we are going to discuss on the XNET usage in the LabVIEW, like how we are going to use it. Okay, I'm Satish Kumar as a certified LabVIEW architect. So we are going to see on to that. Basically, like let's see the difference between the serial communication as well as the CAN, how it works. So in serial communication, we have the two cables, one is TX and RX. So we have a two wires which are the RX and TX, which can be used in the DB9 connector. And if you see for the CAN, so it is also be used in the DB9 connector with CAN I CAN low. So two cables will be used and it will be having the CAN I and CAN low. If required, we'll be connecting the ground for the CAN. Hmm. In serial communication, this communication will happen between the two nodes, node A and node B. So this communication will happen only between the two nodes. Like when the request is sent from the node A to B, B will respond for that. It will be vice versa. And for the CAN, it can be possible with more than 100 nodes. Like we can connect within the network. So basically, like CAN is kind of a network communication. Like it can be connected with one node to another. Like it will be the communication is possible between the multiple nodes. It's so each and every will have a unique ID. So the messages whatever is passing, right? So that will be having a unique arbitration ID. So like serial communication, it will have the priority acknowledgement bit, checksum, and retransmit end of message, and message length can be done through the software communication. Similarly, for CAN as well, we have the hardware support. This will be done for serial, it will be in the software side, and in the CAN, it will be done in the hardware as well as on the software. In hardware, receiver supports priority acknowledgement, CRC, retransmit, and end of message and message length. So these will things will be done in the hardware side. Okay, so if we go for the baud rate of the speed, basically the speed of the serial communication will be baud rate will be up to um, 11,050 um, 11,000 sorry 11,500. Okay, uh, that will be the baud rate for the serial communication. When we compare to when compared to dual wire CAN, so it can be up to 1 megabit. So this is for the CAN, and if you go for flexi CAN FD, it will be up to 8 bits. Okay, when we start with the CAN, so we have a low speed scan and high speed CAN. In low speed CAN, we'll be starting from 32 kilobits. Okay, up to 250, we'll call it as slow speed CAN. Above 1250, we call it as high speed CAN up to 1 Mbps. If it is going more than 1 Mbps, then it will be a CAN FD. Yeah, in serial communication, it will be basically based on the usually it will be a request and response. So when you're sending some request, you will get the response in the command. So in CAN, it's not like it's a periodic transmission. Like all the data will be transmitted over the network. Like a corresponding ECU can fetch the message and can fetch a message and can use it for the post processing. And this is how the serial communication as well as with the CAN communication will differ. So in CAN, right? So when we have the length of cable, so the we have to use the termination resistor to maintain the impedance over the network. So requires to termination resistors. I mean, like it will be connected parallelly to the CAN high and CAN low. So how the connections will be given. So for example, for RX, when RX is the receiver end and TX is the transmission end. So for node A, if RX has to be connected to the TX of the node B, then TX of node A has to connect to the TX of the node B, and ground cable has been connected. Similarly, for dual wire CAN, we have the CAN high and CAN low. So this will be connected with each and every CAN node controller. So this RT they have mentioned here, right? So this is going to be the, so this RT they have mentioned, right? That is going to be the termination resistor. So when we talk about a CAN voltage level, right? So we have the CAN high and CAN low too. If it is a CAN high, so it will be from 2.5 volt to 3.5 volt, and when it is a CAN low, it will be from 2.5 volt to 1.5 volt. So when the communication happens, right? So it will be within this up voltage range, CAN high and CAN low, like recessive bit and dominant bit, right? So this will be with a continuous of like kind of a pulse, like based on the data, the width will change. This is how the CAN bus voltage will be. So now we are going to see variations of CAN. So variations of CAN in sense like what kind of different types are being available. For example, like we have a single wire CAN as well dual wire CAN, and based on the baud rate, it has been differentiated like uh, from 33 kilobits to 1 megabit. Already I've just told you, like if it is starting from 33 kilobit up to 250, we call it as low speed CAN. Up to 50 means below, less than 250. Even 250 will be the high speed CAN. So from 250 kilobits to 1 megabit, it will be a high speed CAN. If CAN communication is happening above 1 megabit, it will be a flexible data rate. It means a CAN FD, we call it as. So, and in CANs, based on the speed, it has been differentiated as low speed, mid speed, and medium speed and high speed. Then, as I said, flexible data rate up to 8 megabit. So this will be from 1 megabit to 8 megabit. And extended messaging. So normally CAN low speed and high speed, right? It will be in the extended messaging will be up to 11 bits. So if you are using CAN FT, then it will be a 29 bit. Uh, that's what's like it differs like normal CAN as well as the CAN FT. So if it is CAN FT, it will be 929 bit. And payload size, for payload size 0 to 8 bytes, right? It's the normal payload size like for the all the CANs. It's exceptional to the CAN FT. For CAN FT, it will be a 24 bytes. Sorry, 64 bytes. Then we have CAN and channels like in frames, right? CAN frame, so which consists of attribution ID, or whether the message is a CAN data or CAN 2.0 or CAN FD, so that will be mentioned. Then the payload. So these were the information which has been stored in the frame. When it is comes to the channel, the variable that maps to the frame, right? So that will be transparent to the developer, which will be mentioned in the engineering unit. For example, the frame has 6 or 7 channels. Channels is basically a signal. It has a 6 or 7 channels, like which is related to the temperature. For example, we can call engine temperature, pedal temperature, uh, outer temperature, and cluster temperature, this environment outside temperature, and chassis temperature, like that. So we have multiple temperatures. So all the temperatures will come under the single frame. So it will be with multiple channels. So each channel will have the starting bit and bit length, as well as will have the conversion factor, like basically offset, as well as the scaling factor. So based on this only we can find the engineering unit, I mean the real value, the actual temperature. So those informations will be can be used for the conversion from the hexadecimal of the payload. Then we have several software driver used by the OEMs, like for their standards, right? For the particular OEM products, they were been following the standards like ISO 15765 and ISO 14229 and KWP 2000 and CCP XCP. So these are the software layers which has been followed by the OEMs. Often these protocol facilitate multi-framed messages, and this is how the wiring communication looks like multiple nodes will be connected, and opposite end it will be with engine and cluster, everything. So how the CAN bus looks like, CAN network basically. And so as of now we have just saw something generic about the CAN tool. So CAN, about the CAN. Now we are going to see on the NI software tool which can be used for the CAN protocol. There were two main driver types, like one is XNET, uh, XNET, like which supports older version as well as with the newer one. And there were older were using called NI CAN, so which supports frame and channel API on most hardwares. So basically, like XNET, which has been more modernized version of the NI CAN, like where it can be, we can able to design our database like a DBC file as well. We can create our frame signals, and whatever the APIs which has been given for the XNET, right? Those are like user friendly and can uh, do the coding very easily, and it was like very easy to use the APIs. And we can also create a multiple session at a time. So this is how XNET has been. And in the measurement IO, right? So just I have just highlighted like how where the NA CAN, this is NA CAN protocol, as well as this is NA XNET. So these are both are like a external package we have to install from the NA package manager, XNET as well as NA CAN. So now it has been completely like people who have started using the XNET compared to CAN. So apart from this, there were but two additional packages. One is called Automotive Diagnostic Command Set, and we have a ECU measurement and calibration called ECU MC. So these tools can also be used. So if you are planning to use do some diagnostics commands as well as for some calibration purpose. So basically what these tools do, right? This in automotive, like if we have set of variables which will be decoded in the A12 file. So if you want to read those variables from the A12 file, then we have, that's basically a diagnostic command set. Like if you want to do that, then we can use the automotive diagnostic command set, and ECU measurement and calibration can be used to read the XCP and CCP data from the A12 file. That's also from the ECU. Fine. Then basically, like now we are going to just check on the XNET database editor and bus monitor now. So how the database editor and bus monitor. So in the PPT slides, it will be a short and just describe you about like what we have. Okay. Separately, I will be showing you the application demo, like in the application now we would able to create the frame, create the signal, and how to um, convert that into a DBC file. So these are the things like what we could be able to describe. Like I'll just explain it in the PPT as of now, and separately I will just explain you come briefly onto the database editor and bus monitor. So in the XNET database editor, so we could able to define the frame and the signal. So which is used in the session is done through the database editor. So database editor can be edited through an API. It can be creator or editor at the runtime as well when we are using in the LabVIEW. So here we can import the DBC file which has been created in Vector, Peak or Canoe or any other different packages. The DBC file can be imported here and can be able to modify as well. And multiple inputs and multiple output mode also has been will be supported here. Like we can create a multiple session in the single port and can be able to transmit the frames and signals. Okay. Here when we talk about the frames, right? So we have a frame input and frame output. In frame input, we have like queued data, single point, and stream data. Similarly, it is available in the frame output. Frame output means like we'll be reading the entire frame as an input and entire frame as an output. So if people are not just want to read the entire frame, like in high level engineering units, they want to read, then the people can go on with signal input and signal output. Mostly like if you wants to instead of going with the frames, if a developer is more required the RPM and temperature, the engineering unit directly, then we can use on this signal input like signal point and waveform and XY. So basically this will give the DBL data, RF DBL data, and that can be used directly into the code. So I'll just show you the example code for each and every things, like for example CAN input, frame input, frame output, signal input and signal output. For this I just show you the example code and how we can do the coding with the low level APIs. So kindly refer to the database editor video, so which will be deeply describing about the database editor. And similarly, we can just refer the CAN bus monitor. In the CAN bus monitor video, I have just not connected the hardware, just to show an example like how it functions. Yes. So now we were been into the part, like, so these things I think mostly I can cover uh, like a theoretical part now, and I've given the separate video where I can able to go through the code walkthrough and explain each and every functions as well. Okay. When we talk about CAN write mode, we have a stream, queued, and single point. So we are just going to see like how we are frame write mode has been working. So this is a basic example code where we have this, like we have the frame list as well. We have this interface. Then it will create the session. After creating the session, we'll be writing the data into the frame. This is how it will be. Then when we are talking about the stream, one write up put onto the data, right, on the bus monitor as soon as is possible. Basically, it means like once the ECU has been just writing the data on the bus, so that data will be lost data, whatever is written, that will be there on the bus. When it is in queued, right, so we can put one by data at a specific time whenever. See, basically, for the when we are just doing that in the database editor, like there will be the time we have to just mention about the recession, like how frequent the data will be transmitted. So it will be in seconds, 0.10, 0.001. So if you mention the timing, like the polling time, the data of like putting the data onto the bus, right? It will be at the specific time as configured for the frames. So that will be just will be putting the data continuously on the bus. And one more thing, like when the queue is empty, right, without transmitting any data over the CAN bus, so that's transmission will be stopped over there. So for example, like when we are just writing the data, so for this data, so we have the specific time. After that time only we could be able to send the next set of data. So it cannot be done in parallelly. For a year, you can just see. Uh, so here we are just streaming, right? So it's streaming. It will be sense of like once we have written the data, that data will be there in the bus itself. So when we call it as a single point, like data goes out of the rate for the frame and the value sent can be updated at any time. So like we can just update that value. So once the data has been sent to on the bus, like it can be updated uh, in the CAN bus at the any time. It's not with the with specific to the time slot. And one more thing, like it will be in the mode of cyclic mode, like cyclic mode means like that data will be whatever the data is sent at the last, right? That will be repeated like continuously. It will be like cyclic mode. So there are two modes like cyclic and event. So these will be based on the event, and single point will be most into the cyclic one. Those things can be mentioned in the while we are doing it in the database editor. Similarly, for the can read mode also, that is for writing and this is for reading. More probably like streaming, like it will read all the frames since the last read. So now we are just I'm reading on data set of data after some 2-3 seconds. Like if I'm trying to read, so from the last reading, so to the current reading, whatever the frames has been passed on the canvas, right? All the data will be read. So when it is like queued, so this also returns all the data since the last read, but only the single frame ID. It's not the repeated. So once, for example, like one frame ID has been sent on data, and the next time it has been updated the value. That updated value, the recent value will be taken in the queued. When it is in the stream, like so for stream attribute ID, the two data will be received. That is the difference between the streamed and the queued. So now we are going to see on the single point. Reads Read returns the last value of for the each frame. So only the last recent value will be there. If value is not used, if bus is not updated, only the default value will be read continuously. So this default value, right? These default value also will be mentioned in the database, like when we are creating the signal. Basically, it's for the signal, like we will be able to mention the default value. So as of now, we have just gone through with frame read and frame write, basically frame input and output. So in the demo, so we'll be covering like simple VA, like how with frame in session will be created and how it will be used, like using the initialization, wait, read, and clearing the session. And database is only used to define the baud rate in this example, like we'll see it in the example. And one more thing is like if we are trying to read as a frame, entire frame, then we'll use the database or the cluster name. Database means like inside this database we have the form of a cluster. Then we'll have the frame, and then signal will be coming up. Uh, so if you mention the cluster name, so we could able to read all the frames which is included in the cluster. So similarly, like we can do it in the code. So kindly refer the code walkthrough video which has been given separately. So far we have been seeing on the CAN frames, right? Now we are going to check on to the CAN signal. So what we are going to deal with the CAN signal is like this will be the actual engineering unit. So for example, like if I just want to read the temperature or RPM or like pressure, those kind of engineering units, right? That can be read using the signal directly. So here also we have the three different things. So we'll see on the like stream, queued, and single point. So for example, this is a code which has been for the CAN single point. So here I just I will explain you like owners for read and this is for write. So which a code which is in the top right, that is for reading the data, which is in the bottom is for writing the data. So these data over current, over voltage, voltage and current. So these are the signal names which has been attached to the DBZ, the frame. So these will can mention the signals directly, and we are just opening the CAN interface CAN one, and we are just we are reading the data here and just clearing the port. Okay, so parallelly what we are doing is like we are writing some set of data onto this scan signal, and we are setting up the values. Analog output as 2.5 and digital output as 1, digital output 2 as 0, duty cycle as 50 and frequency as 100. So when you're setting up these data, so it will be set to the signal single point. So and then after 100 milliseconds of time, just we are trying to read the signal. Okay. This XY graph means it's just trying to plot the data on the graph. That's it. Like, so for this also just you can refer the XNET signal video, which will explain in depth on the CAN XNET CAN single point, I mean signal input and output. So apart from this, right? So we have some utilities like utility in sense of like modifying the database and importing, exporting. Those things can be done programmatically as well. That we can do it and add support for frames. Basically, like if you are reading the data in the frame and if you want to convert that frame into a signal, so this kind of conversions and taking the default values or signal units. So these things we can able to do it here. So for more reference, just you can refer this link. So this is some of example image like I just want to explain us. We are they are just mentioning the frame and DBL and just we are making this into a signal and data converting into a frame, and again the frame from the frame I'm just taking the signal value alone. Again I could able to convert that in this frames, right, frames into a XY signal or like waveform signal. This conversion is also possible in the XNET. So this also can just refer to the video. And just we have been going through with NI CAN, right? So these are some of the basic things like which we can use it for measuring the DTC. So DTC basically the which is for the diagnostic purpose. So just if you want to do some protocol with diagnostic, then we can use this tool. And and if you want to interface the vector CAN or like if you want to try with PCAN, right? So that also is possible that we can try to read those data over the LabVIEW itself. Just you wants to check those like they are providing individual. This is like vector vector package we have to install on the LabVIEW. So to access their hardware, so this is about like how data read will be. So this they are just given in the state diagram. Just you can refer it like if you are trying to make some individual application or like a individual module, like where what are the uh, states and what are the s- process we have to include and to make it into a sequence. Just you can just refer to this. This data logging, right? So in data logging also can be done directly for the CAN. It's with the TDMS and BLF. BLF will be with the Canalizer Vector Tools product, and mostly in NI we have been using TDMS that can be imported and viewed in the diagram. Okay. So the summary, like automotive CAN is about like it's like not going away. Like it will be coming up with the latest versions and like a lot of new things has been coming up in the automotive and like so it is like more cheaper and enough like people started using it in many applications like we'll that's what like how we can you make have to be understanding the can automotive can for our application how it can be implemented and we have to for if you take NA CAN and XNet, right? So mostly like we've been using like NA XNet, like which is a better driver support and more features and easy to use as well. And XNet API is common between CAN, LIN, and FlexRay. So as of now, we have been seeing only on the CAN part. So it is similar for the LIN as well as the FlexRay. Extended conversion libraries also can be used for the frame to signal conversion, and signal to frame conversion also has been possible. Without the hardware, we can use those conversion libraries. Yeah, it's an end of an session, and we'll be back with the demo on the database editor as well as on the code walkthrough. Thank you.